All right, so here are our final notes for this unit. We're going to be solving radical equations. These are the steps. If you need to pause the video, go ahead and do so, but we're going to go ahead and start with problem 1. So is our radical isolated? There's nothing before it or nothing after it. So this one's isolated, so is number 2. Number 3, this 5 we need to get rid of, so we'll come back to that. But we don't need to do step 1, so it's a square root, and if you look at your index is 2 for a square root. So that's what we're going to raise both sides to. We're going to square both sides. When you square a square root, that cancels out, so you just get x. And how much is 5 squared? That's 25. So we say check for extraneous solutions. Just double check. Does this actually work out? What's the square root of 25? Well, 5, and that does equal 5, so we're good. Sometimes you will have answers that appear to be correct, but then they don't actually work out. All right, so number 2, is our radical isolated? Yeah, so we'll move on to step 2. We're going to square both sides. That cancels out our radical, so we have x minus 3 equals 25. Now we need to solve for x. So x is not by itself. We need to add 3, and we get x equals 28. So that is my answer, and I'm just going to go back to the original problem to check. So 28 minus 3 is 25. What's the square root of 25? That's 5. And does 5 actually equal 5? Yeah, so we're good. All right, this one we have to isolate. So to undo the plus 5, we want to subtract. We get square root of x equals 7. So now we want to square both sides. You're going to square, square. That cancels out your radical. So you get x, and 7 squared is 49. Okay, another way to check, you could also just do this in your calculator. So square root of 49 plus 5, and make sure that that actually equals 12. So that's good. All right, flip to page 2. So again, if we're going too fast, make sure that you go back and rewind the video. All right, is your radical isolated? Well, yeah, there's one here and one here. So we're going to square. All right, so if you square it, you get just x plus 6 equals 2x minus 3. The square and square root cancel. So now you have a normal-looking equation that you can just solve. 6 equals x minus 3. If you add 3, you get x equals 9. All right, so let's double check that that really works. So the square root of 9 plus 6 should be equal to the square root of 2 times 9 minus 3. And yeah, we get the same thing on both sides, so it must be correct. All right, this one's a little different because it's a cube root. So if you look at the steps, it says if it's a cube root, you want to cube both sides. So we want to cube it. That cancels out our radical, and 4 to the third is 64. That's not too bad, right? One step. So let's double check. What is the cube root of 64? And that should equal 4. So we are good. All right, number 6. Our radical is not isolated, so I'm going to divide by 3. And that gives me square root of x equals 2. Now that it's isolated, I can undo the radical by squaring both sides. So that gives me 2 squared, which is 4. All right, so let's double check that that really works. 3 times square root of 4, the answer should be 6. Hey, 6, that's good, right? All right, this one, the radical's not isolated. It's not the only thing on the left side. So let's move this over. If I want to move something, I just add it to the other side. So that cancels out. So we're really just going to rewrite it so that the one radical's on the left side and the one radical's on the right side. Now it's just like problem number 4. So to undo our radical, you square it. That just cancels out the radical, and you're left with x plus 2 equals 2x minus 5. So now you have a pretty basic equation. We've got 2 equals x minus 5, and you add 5, and you get 7 equals x. All right, so this would be a nice one to check to see if you have the right answer. So square root of 7 plus 2, I'm going to close that parentheses, minus the square root of 2 times 7 minus 5, close that parentheses, and that should give me 0. And it does. Okay, so when I check, I always go back to my original equation. All right, is my radical isolated? Yes, so I square, square. So that cancels out, and I get 2x plus 3 equals x squared. Now to solve for x here, because we have a quadratic, I'm going to move everything to one side, have it equal to 0, and I get negative x squared plus 2x plus 3. So now you can solve however you want to with the quadratic. You could factor if you want, but I'm going to use the A quad program. So we did this back in chapter 6 or unit 6. So A is -1, B is 2, and C is 3. That just comes from the coefficients here. And I'm going to choose a decimal answer for now. And it says that my answers are -1 and 3. Alright, so this is usually where you might have an extraneous solution. So let's double check. Alright, I'm going to write this one out. So we got 2 times -1 plus 3. That is supposed to equal -1. Then I'm going to check the other solution, 2 times 3 plus 3, and that should equal 3. So you can do it on your calculator if you want, but this is -2 plus 3, so that's square root of 1. What's the square root of 1? That's 1. Now this is not the same on both sides. That's false, right? So this is an extraneous solution. It was an answer, but it doesn't work out when you check it. This one, 2 times 3 is 6, 6 plus 3 is 9. Square root of 9 is 3. So 3 does equal 3, so that's good. So this answer works. This would be an example where you have an extraneous solution. Alright, last problem. I have this fractional exponent. So we always look at our index, our denominator, and rewrite it as the square root of x minus 3 to the first, which anything to the first power is just the square root of x minus 3. So now it's just like any other problem that we had on this page. If I want to undo a square root, I square it. So this cancels out. I'm left with x minus 3, and 4 squared is 16. Now you just solve for x by adding 3, and you get 19. Alright, so final step. You can go back to your original problem, and you type in 19 minus 3 to the 1/2, and that should equal 4. Alright, if you want to check this way, square root of 19 minus 3, right, that should also equal 4. Alright, so that is our final answer. And then we're all done with Unit 7.